For over a century, military power has rested on three foundations: industrial capacity, access to energy, and technological superiority. The First and Second World Wars were fought by nations that could produce more steel, build more ships, manufacture more aircraft, and secure uninterrupted supplies of oil. Throughout the Cold War, the competition between the East and the West was sustained by industrial production, nuclear technology, and reliable access to energy. Things have changed substantially lately. Firstly, nations are competing for dominance in rare earths, elements, and critical materials. Secondly, future armed forces are likely to be smaller in manpower but far more technologically intensive. Thirdly, all armed forces will rely heavily on rare earth elements for powerful magnets, advanced electronics, precision guidance systems, lasers, and communications. Fourthly, space will become an operational domain as at par with land, sea, and air. Fifthly, governments will seek secure access to mines, refineries, semiconductors, fabrication plants, and manufacturing facilities. And lastly, strategic stockpiles of critical materials may become an important as petroleum reserves once were. The next era of great power competition has already begun. It will not replace the importance of oil overnight, but will increasingly be defined by who controls the materials, technologies, and space systems upon which the modern civilization and modern warfare will depend. We now move on from Earth to space. Transition to electric cars, satellites, wind turbines, AI data centers, fighter aircraft, and smartphones. Oil powered the 20th century, but the 21st century and perhaps the next millennium will run on rare earth minerals. These little known elements are becoming the strategic foundation of artificial intelligence, electric vehicles, advanced weapons, robotics, renewable energy, and space technology. Nations are already competing fiercely for the control of them. So let's examine what the vitals really are. They are, firstly, which rare earths matter the most? Second, who dominates the technology? And third, where these critical minerals can be found. Let us now see which are the most important rare earth minerals. Firstly, neodymium. It is the backbone of the modern electric age. As the world electrifies transportation and industry, demand for neodymium is expected to surge dramatically. Secondly, diaposium. This rare earth allows magnets to survive extreme temperatures that make it essential for advanced fighter aircraft, hypersonic weapons, electric vehicle motors, and space systems. Thirdly, is terbium. For advanced display systems, lasers, sonar equipment, and green energy technologies. Fourth comes europium. This mineral powers red and blue phosphors used in digital screens, televisions, medical imaging, and night vision systems. And finally, yttrium. The element is critical for lasers, supersonic ceramic armor, aerospace alloys, and advanced communication systems. Where are these metals found? Rare earth minerals are found across several strategic regions. China possesses major reserves in Inner Mongolia and Sichuan. Australia has emerged as a major alternate supplier. Large deposits are also found in the United States, Canada, Greenland, Brazil, Vietnam, Myanmar, and several African countries, especially Tanzania and Madagascar. India, too, possesses significant rare earth reserves, particularly along the coastal sands of Kerala, Tamil Nadu, Odisha, and Andhra Pradesh. The emerging blocs, therefore, now are firstly, the US led Democratic Technologies Bloc, which would have US, Canada, Australia, Japan, South Korea, EU, and New Zealand. The second bloc is the China led bloc, which would have Pakistan, Laos, Cambodia, Myanmar, Central Asia, and the Belt and Road partners. The third bloc which emerges is Saudi Arabia, UAE, Indonesia, Brazil, Turkey, and South Africa. And the fourth bloc will consist of Australia, Canada, Tanzania, Greenland, Kazakhstan, Mongolia, and Namibia. Who are presently the leaders of rare earth technology? Firstly, we have China, which is the undisputed leader in rare earth technology. It controls much of the world's refining, magnet manufacturing, and processing capability. Even when minerals are mined elsewhere, many still travel to China for processing. The United States remains the second leader in advanced applications, especially in defense systems, aerospace, semiconductors, and AI infrastructure. Japan is the master of precision rare earth technology. Japanese firms lead in high performance magnets, especially alloys, robotics, and miniaturized electronics. The major suppliers could be Canada, South Korea, and the European region, Vietnam, and Brazil. However, by around 2045, a plausible distribution of global rare earth value chains could be firstly, sitting right on top would be China, with 40 to 50% of the global processing and the largest integrated manufacturing base. Next would perhaps be the United States and its allies, including Australia, Japan, and parts of Europe, with 35 to 45%, with strengths in advanced technology and defense applications. India and the other two emerging producers would only be from 10 to 20%, driven by the domestic industrial growth and selective export capacity. The other regions and the remainder often specializing in mining or niche processing. What political adjustments would have to be made by 2050 to ensure that there is no political fragmentation and there is a uniform growth for all? This is one of the central geopolitical questions of the 21st century. If the objective is to avoid political fragmentation while delivering sustained growth, the international system would have to evolve away from both complete globalization and also competing isolated blocks. It would have to become a multipolar body with a broad-based cooperative system. Do we have the foresight, cooperation, and ability to do this? Let's step boldly into the future.